Our initial concept for the ground control support of the International Space Station and mission control had every console staffed with what would be the equivalent of a specialist. They had one level of knowledge that they were to achieve to become a certified flight controller, and that was it. As we marched along with 24/7 ops, we realized that this shuttle paradigm again would no longer be applicable to ISS and started to challenge ourselves to think about different ways of doing business. One of those different ways, we were able to combine certain systems. We combined, for example, a power system and a thermal system and a life support system into one console position that would watch over those systems while the crew slept. And that was called the Gemini concept. We rode on that for a few years, but as the station grew, those combination of systems became a little overwhelming. So we had to look at a different concept. In our new concept, we have come up with a striation of responsibilities, operator and specialist, very similar to the concept that we outlined for the crew members. The operators would be able to safe the system, operate nominally, safe the system, and be able to safe the crew in a given situation. Once the situation had stabilized, they could then pick up the phone and call a specialist who would then come in to help them resolve the problem. In addition, the specialist would be capable of doing other nominal tasks that were dynamic in nature, like EVAs, spacewalks, or robotics operations, or visiting vehicles docking to the station or undocking to the station. Now, these reassessments and continuous looks at how we're doing business are something that we do in mission operations every day. We try to be proactive, try to be ahead of the game, make sure that we minimize the workload on our employees. That was one factor, but also recognizing the fact that budgets are ever shrinking, and we want to make sure we are as efficient as we can be and be ahead of the game and try to provide the best bang for the buck, if you will, and still not compromise safety. As we broke down the function of the flight controller into the operator and specialist level, in order to make sure we did not lower the bar to an inappropriate level, we did a very detailed assessment of each flight controller's individual responsibilities, wrote down all of their responsibilities, wrote down what it would take to train each of those responsibilities, and we were able to reduce the flow that way, but noting that we were unwilling to compromise on things that would call into question the console operator's ability to safe the vehicle or safe the crew. Given that NASA is not the only one facing future budget reductions, our international partners are also on board with this concept and have been performing similar analyses for reductions with their flight control teams. For exploration, things to consider with your flight control teams. You too are going to be faced with budget challenges, undoubtedly, and you will need to keep in mind that the more efficient you can be, the better off you will be in that constrained budget environment. However, it's also important to be sure you too know where to draw that line of safety that you are unwilling to go under and make any compromises. Also, with ISS, we have the benefit of 24/7, 365 days a year operations that we can maintain our flight controllers' performance levels and proficiency. For exploration, you may not have that luxury. So in addition to making sure your team is streamlined and as efficient as possible, you need to ensure you have plans to make them as proficient as possible.
As far as finding efficiency goes, one thing that traditionally we have been able to do, both on the shuttle program, but then also on the station program, is as the program evolves, we have been able to find efficiencies in how we staff our ground control function, and we had for station, we had to be pretty deliberate about it. We had a situation where, and it had started from early in the program, where people spent years of mostly self-directed training to get the knowledge required to do the job, which which for what we're doing early in the program, that was really the only way to do it, because we didn't have a full understanding of how the vehicle worked, and a really kind of gold plated training analysis on what people needed to know to do their jobs. Well, we did get to the point where, let's hit the pause button and do a training needs analysis, or a TNA that we call it. And we sat down, and we spent quite a bit of time doing this. I think it was at least a year, where we went and looked at every position in that control center, and we looked at what do these folks need to do, and down to the individual task level in a lot of detail. Because after we'd been operating for, I think at that time it had been about 7 years since the U.S. lab had been running, we now had that knowledge. And what we're able to do is to take that and then look at our training programs and really streamline them into classes and simulator sessions, where we could effectively tie the session with the task that that person needed to do. And what we're able to do is really get people from hired on being on console. We're able to do that a lot faster, which really, from an efficiency point of view, allowed us to take someone, we say off the street, but get them into the control center faster, which means that we're not paying them to sit around and learn, but also that it's more exciting for the individual as well, to be working on console faster. But we picked up this efficiency as we went. We got better and better at figuring out what people needed to learn, and what maybe we didn't need to pay attention to. And you can probably expect that on future programs as well, that your upfront investment on manpower and amount of time it takes to understand a system is going to be relatively high. And then over time you can reduce it, as long as you do a few smart things, like, as I mentioned, hit the pause button and just stand down and spend a little bit of time making sure that that what you're training is actually appropriate for what people are actually doing. How it extends to exploration is that I think when you start, we're going to have systems that maybe we don't fully understand how they work in space, and we will probably have people that have to be almost self-directed in a lot of their training, or they're going to need to spend a lot of time with the development community, or sitting side saddle on some of the early missions to essentially understand how everything works. You want to make sure that you don't fall into the mode of doing that, in the months and years that follow, without really looking at, hey, we to the point now where maybe we can transfer a lot of this knowledge into people by doing some other things. One of the things we did for Space Station is we used to we still have what we call the Big Iron Simulator, the Space Station Training Facility, which really is a great simulator that simulates all the systems and hooks up with mission control, and it's a wonderful thing, but it's very expensive to operate. By going through and what we do is we'd be running two of these sims a day. We'd have a lot of people in there. Because you can only focus on individual disciplines, for little pieces of the simulation, you would end up essentially not being very efficient in how you use that simulator time. Well, as we went through this analysis, what we came up with is, for all these little tasks, if we had kind of that simulator, but sort of in a little box, in a smaller footprint, both computer-wise and cost-wise, we could do a lot of this training sort of one-on-one. It could be a lot more efficient. It could be a lot more directive. It would be a part task trainer. And we're able to do that. It turned out early on in the program, we wanted to do some of that. We just didn't know how to do it. Part of it was we didn't have the technology to run the full suite of flight software on a small computer back in the mid 90s. And as part of the process of trying to find these efficiencies, we actually realized, we can actually basically shrink that entire simulator down into one box, one part task trainer, and use it to train individuals a lot quicker, mainly because just the training was more focused.
I focused mainly today on a number of operations related lessons learned. We've talked about making sure you get your ops concept clearly identified in the requirements definition phase. We've talked a bit about crew training, flight controller training, and there are a number of other operational lessons that I did not have time to cover today. The important thing is there are lessons to be learned, some of which on ISS, we did a good job in learning from the previous programs, and some of which we did not. So I encourage you for exploration. Take the time to study the space station's lessons learned. If there are questions that you have that are operationally related that I did not cover today, I would certainly be happy to take the time to provide you either information directly or to put you in contact with the appropriate personnel in mission operations.
Some of the challenges that we got in the future, and some of the things that, as I work on some of these advanced missions that I hope to bring as a space station flight director, is getting into these missions where we leave the Earth and we're gone for some number of days, and the crew's got to have a real level of autonomy from people like me on the ground that can help them out in short notice. And there's so many things that we've learned from space station, like regenerative eclipse, which is something that even until a few years ago, I don't think we would have been able to pull off on a longer mission. To how folks exercise in space. We've gotten to the point now where when the crew comes back from a long duration space mission, they're actually fairly mobile. And I remember the early days where that wasn't always necessarily the case. I mean, it's really exciting to see as we go through the space station program how we're learning how to really function operationally in space. And now we got to go ahead and project that into some of these longer missions. Things like, how do we deal with the hostile radiation environment? That's something we need to do for Mars, that you really can't experience on space station. You're not forced to because you're below the Van Allen belts, but somewhere, um, in between, like in cislunar space, you get some great operational experience in doing it. And it's funny because you can do a lot of this stuff on paper, but until you actually put together a mission and fly out there and you're forced to deal with it, that's the only time that you learn about it. I've been reading about regenerative ecosystems, that recycle urine into drinking water in space. I've been reading about those for the last probably 35 years, and how these are going to work. But actually, I don't think any of it actually really worked until we flew it just a few years ago on space station. And now it works pretty well, probably getting onto the point where we could rely upon the next generation of those systems to go out where we don't have the maintenance capability from the Earth that we do with the space station. So I'm really excited about seeing those sorts of things. I'm excited about working on them. I'm really excited about the engineering and just learning about how to kind of push ourselves out from the Earth and become more of a species that travels around in space instead of it just being limited to the near Earth neighborhood. And it's really exciting to work on. So I anybody that knows me knows that I don't really hesitate to talk about all the things that we've learned in 10 or 15 years. So and I've only maybe just touched upon a few of the things here with you. So certainly feel free to contact me, and I'll either pull up a chair and talk to you for a while on the phone, or I've got a lot of really smart people that I know that work here that I'll put you in contact with, and we can share some stories and hopefully give you some knowledge that you can use for the future designs.